This is section 2, algebraic approach to limits, example 5. So you took pre-cal because you've got to know what all of those functions look like, including sine, cosine, tangent, and all those trig functions. And so now we're going to use a little bit about what we know about trig to manipulate these equations and make them a little bit easier. Now, when you're dealing with the limits of trig functions, there's two that you absolutely have to know that could very easily come up on the test as an issue, or as a problem, which are made simpler by just memorizing them, and they are this. The limit as x approaches 0 of sine x over x, and the limit as x approaches 0 of cosine x minus 1 over x. All right, and you might have to do some manipulating of equations to get it into that form. Now, when you're doing the sine of x over x, notice, if we go over here, right below it, if it's sine of ax over x, it's just a. And if it's sine ax over bx, it's a over b. And so those are just some variations of that rule. Now, let's go ahead and use it. Well, let's look at a. Right? A is the limit as theta approaches 0 of sine of 3 theta over theta. That's just sine of ax over x, where a is 3. So the answer is 3. Done. Makes life very easy. For part B, they're not set up that way. However, what you do at the top, as long as you do it to the bottom, it's valid. Okay, you're allowed to do something like that. And so what I'm going to do here is I'm going to find the limit as theta approaches 0 of sine 5 theta over theta over sine of 2 theta over theta, which I'm allowed to do as long as they exist. So because I divided the top by 0, I'm allowed to divide the bottom by 0. And now I can just use that same attribute of the limit that we know and plug it in. So if I have sine of 5 theta over theta, I really just have 5. Right, that limit is 5. And the limit as theta approaches 0 of sine of 2 theta over theta is 2. So that's the answer. You can also split it up by multiplication. So here, the limit as theta approaches 0 of sine of 3 theta over theta cosine of 4 theta. So if I take the sine of 3 theta over theta and say that that's a little bit separate, actually, hang on. So find the limit as theta approaches 0, and I'm going to separate it with multiplication. So sine of 3 theta over theta times 1 over cosine of 4 theta. Now this is not breaking any math laws, right? You're absolutely always allowed to do this as long as it's all multiplication, right? You can do that with multiplication. You can just split it up into its separate pieces. We know what the limit as theta approaches 0 of sine of 3 theta over theta is. It's 3. And, believe it or not, you know what the limit as theta approaches 0 of 1 over cosine of 4 theta is. It's 1. Because 4 times 0 is 0, cosine of 0 is 1, 1 over 1 is still 1. And that's just taking it and plugging it in. So I didn't use any rules, any special things. I just used what I know about trig. Okay, and so that answers 3. Let's look at D. That's supposed to be D. D. So for D, it's going to be a little bit more complicated, and we might be doing something that you might not anticipate happening most of the time, but that's why you have to get creative. So instead of dealing with this ugly fraction, with a fraction over fraction, not a fraction over fraction, addition over multiplication, we can take that addition and split it up. Okay, because remember that denominator goes with both terms in the numerator, right? We just write them all together so that we don't have to write the denominator so many times. So another way of saying this is just the limit as x approaches 0 of 2x cosecant squared x over x cosecant squared x plus cosecant x over x cosecant squared x, right? So I just split it up so that the denominator was underneath both numerators' terms. Now, hey look, well that's nice. There's x secant squared x there on top and bottom. Because there's no addition, I'm allowed to do that. So I'm really finding the limit as x approaches 0 of 2. And then on this other one, I can take out 1 cosecant, right? So it's just 1, it's the first power. So it's 1 over x cosecant x. Well, cosecant, if you remember, is the reciprocal of sine. So I really have sine x over x. And I know what that limit is, it's 1. So I get 2 plus 1, which is 3. Done. And there's nothing really tricky to part E, you're just plugging in numbers, right? So if I have sine of g of 2 plus f of 2, right, because I'm plugging in 2, because that's the limit we're taking, g of f of 2, and I take that and simplify it. I'm running out of space. G of 2 is just, let's see, 0. And sine of 0 is 0. I'm just going to write sine of 0. Oops. Plus f of 2 was 1. F of 2 is 1, so g of 1 is negative 1. So the answer just ends up being negative 1 because that is 0.